Welcome in this screencast about Math for Robotics, in which we will talk about reverse kinematics. Okay, let's start with the base frame. We have two axes, X and Y. We have two robot arms. First robot arm there, and the second robot arm is over there. So each robot arm has a length. Say this is alpha 1 and we have theta 1 angle, and we have the second robot arm also a length alpha 2 and an angle theta 2. And we use some letters here as the point A, B, and say this is point C. So what we would like to do is, given point C, what angles should we use to reach point C with given lengths for the robot arms? So we can do that by making another line here. So we construct a triangle. I will take that one out. So we have a triangle A, B, and C, and we can use here the law of cosine. So first, what do we know? We know that this side is length alpha 1 and the second robot arm is length alpha 2. Actually, this is the blue arm and this is the orange one. Okay, so is there any more information? Well, we know that this angle is theta 2, so this is theta 2. So this one here is probably 180 minus theta 2. Okay, so can we calculate the distance from A to C? Yes, because what is known is the end position of the robot arm in coordinates X and Y, because that's the idea. We know the end position, calculate back what are the two angles. Okay, so we can use the law of cosine here, which says that AC squared equals AB squared added by BC squared minus 2 times AB times BC times the cosine of the angle between the two legs AB and BC. So that would be 180 minus theta 2. But have a look. If you make a small drawing here, upper side of a circle, we have a, say, unit circle length of 1, rectangle circle. So this is your angle theta. Now we have 180, 0, 90, 180 minus the same angle over here. So we see that this is the cosine of theta, and here we have the cosine 180 minus theta. Well, in length they are actually the same, only you can say this is minus cosine of theta. So we put it in over here, so we go a little down and we could say AC squared equals AB squared. Oh, we can straight fill in, because AB you see AB is actually alpha 1 squared, and the AC is of course the length AC, which is by Pythagoras x squared added by I squared. See, AC is x squared added by y squared. So we have here added by BC squared is the alpha 2 squared, the length of the second robot arm, minus 2 times alpha 1, alpha 2. And here we have the minus cosine, so we put a minus over here. Minus minus gets plus, and we have a cosine theta 2. Now we're actually interested in this angle theta 2 because we want to know how big it is. So what we do is bring all this stuff to the other side, and we have 2 alpha 1 alpha 2 cosine theta 2 equals x squared added by y squared, this much over here, minus alpha 1 squared minus alpha 2 squared. So get rid of the 2 alpha 1 alpha 2, they are not 0, so we divide here as well, alpha 1 alpha 2, this is nicely 1. So here we have an expression for the cosine. So if you want to know the cosine of the angle itself, your arc cosine of the whole thing, which is here. Okay, well, this is the idea that firstly you calculate the second angle, and in the next movie we will show you how you can calculate the theta 1 over there. Okay, thanks for watching.